So what is the conservative force? Conservative force means if work done by a force in a round trip is 0, so then force is said to be conservative force. So when we say that this is conservative force, what is the meaning of round trip? Round trip stands for initial and final points are same, means wherever you are starting you have to come back to same point. That's called as round trip. You can follow any path coming back to same point. Okay, na? A is initial, B is final. You start at A point, go in a rectangle and come to the same point. It's also round trip. Now you start at A point and go in some random path and come to the initial point. So what is the example for conservative force? The example for conservative force is gravitational force. Gravitational force is a conservative force. And the next, spring force. Spring force is a conservative force. So similarly, there is one more point, one more force, that is electrostatic force. Even electrostatic force also will store the energy in the form of electrostatic potential energy. So now, what is the conclusion? There is hidden message in this entire board. It will decide the character of a conservative force. See, if a conservative force is there, I am starting at A point and coming back to B point, then what is the work done is 0. He is starting at A point and coming back to A point, what is the work done is 0. Here also starting at A point, coming back to A point in other path. Still, what is the work done is 0. So work done in all the 3 cases is 0. Path is different, you can follow any path, but work done is 0 in all cases. So then what we can write down? We can write down one important thing, work done by conservative force. Conservative force is independent of path followed. Okay, it does not depend on the path, it only depends on initial and final points. If displacement is not equal to 0, work done is not equal to 0. If displacement is 0, work done is 0. That's it, simple. So work done by conservative force is independent of path followed. It's very, very important point. The meaning is, suppose that A is the one point and B is the other point. Now which force is acting? Conservative force is acting on the object. So if only conservative force is acting on the object. Now I will take the object from A to B in path 1. In first path I moved the object from A to B. Now displacement is not equal to 0, it's not round trip. Work done by conservative force in the round trip is 0, but it's not round trip. Then work done is equal to 0, not equal to 0. So work done by force, conservative force from A to B is not equal to 0, no? Now if I move in other path, second path, from A to B only, initial final point same. Even I am moving from third path, something like this, path 3. Like that you can write down n number of paths. But see, object is moved in the path 1, object is moved in the path 2, even object is moved in the path 3. By what force? Same conservative force only. Same conservative force, okay, object is moved in different paths. So work done by conservative force is independent of path followed. That means work done from A to B in path 1 is equal to work done from A to B again in path 2, okay na, is equal to work done from A to B in path 3. In each and every path the work done will be same only, even though paths are different, but still the work done will be same. That is the meaning. The work done in all cases will be same because initial and final points are same. Okay na? So I can write down one more logic. Work done by conservative force depends on only initial and final points, not on the path followed. I can write down Siemens. Not on the path followed. It only depends on initial and final points. So everybody has to follow this carefully. See, this is one level, this is other level. You can say this is initial level and this is final level. Okay. You can say that initial level is screen bottommost point, upper level is screen highest point. Okay, now you can imagine like that. Now I am taking the one block of mass m, I have taken. Okay, now by applying the external force, slowly we have taken to final level. I am taking the one more case, final and initial. Now how we have taken the block? So block of mass m is there. Now we have taken the block from initial level to some other level A. Now A to I have taken B level. Okay, na? Now B to final level. We have followed different path, something like this. How I have taken? In second case, how I have taken the block? Lowest level to some height and horizontally and then vertically. Clear? Finally both are at the same place, same height only. Initial height and final height is same, but the path is different. This is taken directly. This is taken like this. And I am taking the one more case. So I am taking the one block of mass m Now I have taken the block at an angle to final level. Understood? The paths are different. Find work done by gravity in this case, in this and in this. All the three cases, find the work done by gravitational force. Okay, na? The height difference is h. H is the height difference between the initial and final level. How the mg force will act? We require the only work done by mg. So mg is acting downward, and what is the displacement? Displacement upward by what amount? H. Then what is the angle between the mg and h is 180. Work done by mg force is nothing but work done by conservative force. What is the value? Force mg into displacement h cos 180, because it is work done by constant force. So then what is the work done by mg in first case? Minus mgh. I think all of you got this. Case 1. What about the case 2? Second case. So this height, we don't know height, no? This I am writing as h1. This height I am writing as h2. Okay, now this length is L. Work done by weight in rising the h1 height. What is the work done? Total work done I am writing now. Total work done. First, what is the work done in this vertical height, h1 height? I can write down mg is the force, h1 is the displacement. Displacement upward, force downward, cos 180 is the work done. So this is the work done in h1 height raised. Now what is the work done in traveling the L distance horizontally? How the mg will act? As the block is here, mg will act vertically downward, and displacement and mg perpendicular to each other. See, mg is acting downward and displacing along the horizontal. If I move along the horizontal, mg will do the what work? Zero work. Displacement and weight both are perpendicular to each other. Okay, so if you want, you can write down mg into displacement L cos 90 in this path. In this path, what is again work done? Mg will act downward, but displacement is in upward direction. So then I can write down plus mg into h2 into cos 180. Okay, na? So what is the total work done is? Total work done is equal to cos 180 minus 1. So minus mg h1. mgl into cos 90. Cos 90 is 0. So this value is 0. See, work done in displacing horizontal is 0. Work done displacing vertically, what is the value? Minus mgh2. Cos 180 minus 1. So finally I can write down minus mg, I will take it out. What is the h1 plus h2 value? h1 plus h2 value will become h, total height, is equal to minus mgh. So first case, second case same. What about third? Obviously third also you will get minus mgh. Answer should be minus mgh. All of it try. See, this is the displacement, am I right? If you see normal work done case, mg is acting vertically downward, and this is the displacement vector. What is the displacement value? That we don't know. Let us say L is the displacement. L is the displacement, and this angle is 90, and I am taking this angle is alpha. Then what is the total angle between displacement and force? So what is the total angle? This is 90, this is alpha. So what is the total angle will become 90 plus alpha. Now tell me, what is the work done by mg force? Work done by mg is equal to force mg into what is the displacement? L cos of what is the angle between them is? Angle between the displacement force 90 plus alpha. Work done by mg force is equal to mg into L cos of 90 plus alpha. Cos of 90 plus alpha will become minus sin alpha. 90 plus alpha means second quadrant. Cos of 90 means become sin of alpha. What is the work done by mg is equal to, I can write down minus mg into what is the L sin alpha. See, what is the alpha is? This is alpha, and this length is L. Then what is the L sin alpha will become? So this is h, no? That is h. So if you check clearly, this is the thing, L, h, and this is alpha. Now tell me, what is the L sin alpha stands for? L sin alpha stands for h. So I can write down minus mg h. Work done by mg is equal to. So what is the work done by gravity is equal to minus mg h. See, in all paths, if you are moving from one level to other level, initial point to final point, you move in any path. Work done by conservative force, which is nothing but gravitational force, mg. Mg is a conservative force, gravitational force also. Work done by gravitational force is same. Whatever previously we wrote, that we proved. Okay, now this is the proof for previous statement. So this is the statement, no? Work done by conservative force in any path is same. So we got any path is same. Okay, make a note that. What is the increase in gravitational potential energy, or simply potential energy? What is the increase in potential energy of object? That I am writing as delta U. We have taken h height upward, no? Then what is the increase in potential energy of the object? Object of mass m is taken from one height to other h height, then potential energy increases, no, position changed. So as I am taking the object to h height, then what happens to its energy? Potential energy increases. Then what is the increase in potential energy will be? mgh, because we have taken h height. mgh is the increase in potential energy. But if you see clearly, what is the work done by gravitational force? minus mgh. So then what is the relation between work done by gravitational force and increase in potential energy? Work done by gravitational force, increase in potential energy. What is the relation between them? The sum is 0. Very good. Work done by gravitational force is equal to, can I write minus of increase in potential energy? Minus of delta U. Okay, na? This we proved. Work done by mg. Work done by mg is equal to minus of mgh. What is the mgh is nothing but delta U. So I wrote mgh is equal to minus delta U. So work done by gravitational force is equal to minus of change in potential energy. This only I read on. What is the mg is nothing but conservative force only, na? Work done by conservative force is equal to minus of change in potential energy. Okay, so this is valid expression for any conservative force. Write down yourself what is the non-conservative force. If work done by force in a round trip is not equal to 0, then force is said to be what? Non-conservative. Okay, na? What are the examples? The example is friction and all resistive forces. So what is the other resistive force? Is viscous force. Viscous force also non-conservative. Even friction also non-conservative. Work done by non-conservative force depends on the path. Friction, no? Because of friction, what will happen? Energy will be lost. What is the best example? Very simplest example is rub your hands. There is a friction between the two hands. As you are rubbing it, you are doing work. That work done will be converted into heat. Why? Because of friction. Work done by friction will be lost. Okay, na? So remember always one more important term, that is work done against non-conservative force. Okay, will be lost in the form of, mostly in other forms I am writing, simply other forms, but mostly heat. Other forms, mostly heat. So now all of you got clarity on conservative and non-conservative forces and work energy theorem also. Work energy theorem actually I simply did. So now we use mechanical energy conservation.